Hi, I'm Ashwin Nathani, Associate Director of Business Development for iWave's Systems Technologies, and today I'm going to give you a brief overview of iWave's offering for Freescale solution. iWave Systems Technologies is an ISO 9001-2008 certified company founded in the year 1999. And since inception, iWave has been focusing on providing end-to-end embedded design solutions. In terms of technology, iWave predominantly focuses on providing hardware, FPGA and software BSP design services. iWave is headquartered in Bangalore, India, and we have offices in Japan and France. In the rest of the world, we have our presence through reliable partners who offer the local support that is needed for our clients. iWave realized the need to go up the value chain in offering design services. Hence, we came up with a solution that could bring down the development cycle by 50% and also would bring down the cost by sheer economics. We therefore came up with a solution which we call a system on module, which is a module which has a CPU and the memory subsystem and all basic electronics that constitute a system on module which the customer can use to shorten his development cycle. iWave is proud to have partnered with Freescale, and we really cherish this partnership, and we've been one of the early adopters of Freescale's ARM processor platforms, be it the Hydra 2 series, Hydra 5 series, or now the latest being the Hydra 6 series. All of iWave's system on modules offering are very well supported by all the necessary development kit and the software BSPs that help you focus on the application right from the word go. By default, most of the modules from iWave are backed by OS support, namely Linux, Android and Windows embedded compact version being 7. We also have the capabilities and the technical skills to develop a BSP for QNX or any custom OS for that matter. So now let me walk you through all of iWave's offering for Freescale's solution. So what you see here is few of our popular offerings for Freescale's CPU. To begin with, we have a very popular Q7 module solution. We have a Hydra 51 based Q7 module and also Hydra 6 based Q7 module. All the Q7 modules are supported by a dev kit which help you quickly evaluate the CPU and the module and jumpstart your application development. On the similar lines, we do have another module that we term as MXM module, which is slightly bigger in form factor as compared to the Q7. While the Q7 is 70mm by 70mm, the MXM is 85 by 85mm CPU. Also, we have in the MXM, we have a micro MXM standard which is based on the Vibrate CPU. This module that you see here is based on the Hydra 5 series of CPU, and this MXM module is based on Hydra 6 CPU. As the Q7, we also have support for a dev kit for evaluating the MXM module and the CPU capabilities. The MXM module is predominantly targeted for automotive applications, while the Q7 is targeted for industrial, medical and automotive applications. iWave also provides a single board solution. We have a single board solution based on Hydra 508 CPU and SBC in Pico ITX form factor that is based on Hydra 6 series of CPU. focus and see what Q7 standard and where it finds its application and what we have to offer for Q7. Let's take a look. Q7 is a standard defined for modules, and it's originated in as early as 2008. The standard defines not only the dimension of the module and the mechanical aspects, it also defines the signal level for the MXM connector that is recommended to be used for a Q7 modules. So now let's take a deeper look on how iWave has implemented a Q7 module on the Hydra 6 CPU. Starting from the top left corner and in clockwise direction, let me just walk you through the features that are available on this module. The module has onboard micro SD connector, boot mode switch, eMMC flash, another switch, boot switch for configuring the boot media, a RS-232 pin header. You also see DDR3 RAM that is expandable up to 4 GB. You have the JTAG header that is optional. It's not loaded by default, but we could as well load it if required. On the bottom you see the Q7 edge connector, the power input, and you have the optional 20 pin header. And last but not the least, we have the Hydra 6 processor right in the center. This is a top view, and now if you turn around the module, and this is how it looks at the bottom. And if you observe carefully, we have two expansion 80 pin connector. Let me take a while and explain why we put the 80 pin expansion connector in place. We realize that Q7 defines signals for the 230 pin connector, and while the Hydra 6 CPU has many GPIO lines still available for usage. So we very cleverly have brought out these signals to an expansion connector, which we recommend where the clients are running out of GPIOs. It's an optional connector. It is not loaded or not populated by default, but should the client require more GPIOs for their application, we can certainly help them use it using our Q7 module. Now that we've seen what a Q7 module is, let me drag your attention to what we call as MXM module. I know it is slightly confusing that we call this an MXM. At a possible risk of creating a further confusion, let me explain this in detail. The Q7 also has an MXM connector, but it is defined by the standard and it is lesser pin counts as compared to what we have on the MXM module. So in reality, we are using the same MXM, we are using the MXM connector only, but it's just that on the MXM module, we have a larger pin count MXM connector. I hope I'm making sense. So let's take a look at the MXM module, and just to make it a little interesting, I am going to show you how this fares in size when you actually see it alongside with a Q7 module. If you closely observe, the pin counts are higher, and then this module is slightly bigger. So while the Q7 is 70 mm by 70 mm in dimension, the MXM is 85 mm by 85 mm. And just to repeat, we focus on 3 domains for this module, that is industrial, medical and automotive, while The MXM has been predominantly defined or designed for automotive applications. At least the current projects that we are executing involves a lot of automotive clients. Again, starting from the top left corner in clockwise direction, the following are the features that I would like to highlight on the MXM module. We have a micro SD connector, followed by the boot mode switch and boot media switch. Then you have the DDR3 RAM, followed by the 314 pin MXM edge connector. Then you have the power input, followed by optional 20 pin connector, and last but not the least, again the CPU, Hydra 6 CPU. Like we had a expansion connector at the bottom side of a Q7 module, we have a single connector here on the MXM module as well to bring out the unused CPU lines. While the modules that iWave has designed, be it Q7 or MXM, is for clients who would like to have a custom hardware design but still reduce the design cycle. However, there are applications where the client needs a replacement for a computer, and for such applications, we believe that the Hydra 6 based Pico ITX that I'm holding here is a perfect fit for running your applications and replacing the existing system. Unlike the modules, the iWave's Pico ITX based on Hydra 6 processor is loaded with all connectors. And let me just highlight few of the connectors and features that this board packs in. Again, starting from the top left corner in clockwise direction, we have the power input, then followed by an audio out. Here you see the two USB host ports, you have a HDMI out, a gigabit Ethernet 5 and the connector, a USB to serial port for debug console, you have a resistive touch controller and the connector, the LVDS display connector, an expansion connector, a SATA connector, DDR3 RAM, boot switch for selecting the boot options, micro SD card, camera connectors, USB OTG port, and last, again not the least, the Hydra 6 CPU. And at the bottom side, you find few other features like the SDMMC connector and a power management control IC, and of course the PCIe connector. Let me then quickly demonstrate to you where do these modules really get used in. For example, you have a point of sale terminal, you have an industrial HMI device, then you have a panel PC, and here is a solution that's for medical application, which serves as a skin analyzer. The way it works is the client decide which module that they want to embed in their platform, which they can very well do by buying an evaluation kit, start developing the application, measure the performance of the CPU and the module, and then go for mass volume production. On the similar lines, here you find an industrial single board computer that embeds iWave's Pico ITX based on Android MX6 CPU. So that's about it. Thank you so much for watching the video. I hope this gives you an overview of what we have to offer for Freescale's solution. For any further queries, please feel free to send us an email at mktg@iwavesystems.com or log on to our website www.iwavesystems.com. Thank you.